Redox reactions are reactions in which electrons are transferred from one particle to another. Redox is a shortening of reduction and oxidation. You cannot have oxidation without reduction and vice versa. So if you have one, you have to have the other. Many biological processes, corrosion or rusting of metal, and batteries run on this principle. So what is oxidation and reduction? So in oxidation, electrons are being lost, and in reduction, electrons are being gained. So the catchphrase for you to memorize is oil rig. Oxidation is losing electrons and reduction is gaining electrons. So down here I have a redox reaction. In order to figure out what is being oxidized and what is being reduced, you need to assign oxidation numbers first. So magnesium has an oxidation number of 0 because it's an element. Also, oxygen is an element, so it has an oxidation number of 0. Over here on the product side, both of these elements are in compounds. So I'm going to have a different oxidation number than I did on the left-hand side. Magnesium is an alkaline earth metal, and in a compound, it has an oxidation number of +2. Oxygen has an oxidation number of -2. Together, they are neutral. Well, what element gained electrons and what element lost those electrons? So you're going to look from left to right and figure out which ones are changing. And I see that my magnesium has changed, and I see that my oxygen has changed also. Magnesium, going from a 0 to a +2, it has lost electrons. Remember that electrons are negative. So if my oxidation number goes up, that means electrons are lost because negative electrons have gone away. And I can't lose electrons without gaining electrons. So the other one is obviously gaining electrons. So when a negative electron comes in, my oxidation number should go down. That is where the reduction word comes from, because the oxidation number is decreasing with those negative electrons coming in. So when I identify what is oxidized and what is reduced, I say that magnesium is oxidized. And I say that oxygen is reduced. So when figuring out what is oxidized and what's reduced, assign the oxidation numbers, look from the reactant side to the product side and figure out what has changed. And then remember, electrons are negative. So if they're gained, the oxidation number should go down. If they're lost, the oxidation number should go up. So this slide is a summary of what I just said. So again, oxidation is losing, reduction is gaining. When something is oxidized, the oxidation number increases. When something is reduced, the oxidation number decreases. Let's practice in these two examples, figuring out what's oxidized and what is reduced. These are demonstrations that I actually did in the classroom or will do in the classroom. And so that's why they're a little bit different, maybe a little bit harder than you'll see in your homework or what's on the test. But you should be able to assign oxidation number easily to anything here. So coming first to H2O2. Hydrogen is a +1. And I do have 2 of them. That gives me a +2. Oxygen, this is the exception for oxygen. Oxygen in peroxides, and this is hydrogen peroxide, has an oxidation number of -1. So just from the hydrogen, that kind of clues me in. So all my oxygens together should equal a -2 to make this neutral. So that means each of these oxygens is a -1. On this next one, oxygen's a -2. I have 4 of them for a -8. It needs to total a -1, so that means my manganese is a +7. And over here on the right-hand side, oxygen is still a -2 here. Remember, it's only a -1 when it's in a peroxide. So a total of a -4, so that means my manganese is a +4. Here I have the element oxygen. And so for our last one here, oxygen has a -2 and hydrogen has a +1 for an overall charge of -1. So once I have the math, I don't need it anymore. I can just get rid of it. So I'm just going to erase it here just to get it out of the way. So remember, oxidation numbers, the oxidation number for just one is what we're interested in. If you put the math in the oxidation number, it's going to mess you up. So don't do that. So I'm going to look from left to right and see what has changed. So there's lots of oxygens on either side, and some of them change and some of them don't change. But we're going to connect, in this case, these two, because this is my change. Again, this is a more difficult problem that I wouldn't ever give you on your homework or the test. And the other thing that's changed is this manganese. So let's determine which one is losing electrons and which one is gaining electrons. So coming here to our oxygen first, we're going from a -1 to a 0. So remember, electrons are negative. So this one is going to be losing electrons because my number becomes more positive. 1 electron went away to go from a -1 to a 0. So that means my other one must be gaining electrons. And now let's assign what is oxidized and what is reduced. So remember, oil rig. So oxidation is losing, reduction is gaining. So that means that my oxygen right here, just the O, this is oxidized. And my Mn right here, this is reduced. All right, let's move on to the next one. Go ahead and stop the video and see if you can figure this out on your own to see what is oxidized and what is reduced. Okay, we're back now. Let's start off with the Mn2O7. Oxygen is a -2. I do have 7 of them for a total of -14. So that means my Mn's need to be +14. And I do have 2 of them, so that means they're each a 7. So that makes the math all work out. And let's come over to this alcohol group here. So I'm going to start with my oxygens and my hydrogens. So oxygen's a -2, hydrogen's a +1. And I do have 5 of this one right here. And the reason why it's grouped this way is it's giving you a clue of how it's put together. All right, so let's do the math. We have a +5, a -2, and a +1. So this totals a +4. This means that my carbon has to be a -4. And I do have 2 of them, so it's a -2 each. All right, let's go over to the right-hand side. Oxygen is a -2. I have 2 of them for a total of +4. And that means our manganese right here is a +4, opposite charge. Over here we have a -2. I have 2 of them, a -4, carbon's a +4. And in this water I have a -2 and a +1. So I can get rid of my math. I don't need it anymore. So this will allow us to figure out what is losing and what is gaining. And remember, if something loses, something else has to gain. You can't have oxidation without reduction. So my things that are changing are these 2 and then my carbon. So remember, electrons are negative. So let's start with our manganese. So our manganese is going from a +7 to a +4. So my number is going down. So this is gaining electrons. And that means this other one would be losing electrons. And that makes sense because that means my other one right here is losing electrons. Because I'm going from a -2 to a +4, that means electrons are lost. So remember oil rig, so my carbon right here is oxidized. And my Mn right here, this is reduced. And remember, reduction means that the number goes down.